First of all, let me thank all of you for this opportunity. BelHadj Braiek Asma, first year PhD student in Faculty of Economic and Science of Management of Nabil, Tunisia. I'm here to present my work in the field of sentiment analysis classification for text in social media application to Tunisian dialect. First, my plan is composed from 5 main parts: introduction, Tunisian Arabic dialect presentation, the design and architecture of the sentiment analysis TAD system, sentiment analysis for TAD experimented and the result. And finally, I will move on to the conclusion. Introduction. Natural language processing is a branch of artificial intelligence that focuses on understanding, analyzing, and representing all human language as it's spoken and written. Arabic natural language processing involves the development of techniques and tools using the Arabic language. Numerous systems have been created for different applications, such as machine translation, information retrieval, and extraction localization, and multilingual information retrieval systems. Arabic sentiment analysis automates the analysis of vast quantities of text, assisting in the comprehension of people's attitude and opinion regarding specific subject or object. Tunisian Arabic Dialect TAD is the language used by Tunisian people in their daily life, social media networks, blogs, and text message. Tunisian Arabic Dialect presentation. Tunisian Arabic is a Maghrebi Arabic dialect. Tunisian Arabic, known as Tunsi, simply means Tunisian or their dialect, spoken by more than 11 million of people. That is affected by various civilizations that have crossed the country and have influenced the Tunisian spoken. It is nowadays very rich in lexicon known of multiple origins. Let's move on to Tunisian Arabic dialect characteristic. Spelling. That is written from right to left and keep the same short vowel as Standard Arabic. Morphology. Word in TAD follows the same root representation of root schema as in MSA. Inflection is a term used in morphology to refer to one of the two main categories or process of word formation. Aggregation, like several Arabic dialects, affix and clicks in TAD have several differences from MSA. And the last one is the lexicon. The Tunisian lexicon have several issues in many factors. Challenges, like the MSA language, Arabic dialects are sophistically distinctive and have many challenges that make research more interesting in this field. Among them, one can specify the following challenges. That contain many subdialects. Depending on the region, we have chosen that of the capital. The great distance between MSA and some dialects that has neither a standard orthography nor dictionary. Negative word used can change the exact meaning of that in the contrary direction. Our motivation is that has different characteristics compared to other language. Therefore, we need to clarify the reason why we proceed to a more detailed examination of that. Some linguistics find its treatment difficult to handle. Lack of TAD resources available on the net. TAD is very context depending and contain a variety of words that require different specific treatment. Our solution is to create a system for TAD analysis and more precisely sentiment analysis. The design and architecture of the sentiment analysis TAD system. When we deal with the sentiment analysis, there are primarily 3 approaches: machine learning approach that have the linear classifier, the probabilist classifier, decision tree classifier, rule-based classifier, and artificial neural network. The lexicon-based approach in which we have the corpus-based approach and the dictionary-based approach. And the last one is the hybrid approach. For our system, we choose a hybrid approach. Why we choose the hybrid approach? The system we propose is the hybrid system because for Arabic sentiment analyze, only a few papers use the hybrid method. Lexicon-based method combined with the probabilist classifier lexicon approach with machine learning model as like SVM, linear regression, and RNN. The hybrid approach includes the best feature of machine learning and lexicon-based methodology, which allow the provisioning of a lexical representation of the Tunisian dialect with a good classification of sentiment analysis. The system we propose is a hybrid system because it combines lexicon construction approach. Our lexicon construction approach have inspired by the work of Iman Glouli. Our rule-based approach have inspired by the sentiment analysis engine named VADER. Let's move on to the general architecture and the detailed architecture. Our general architecture is composed by the corpus construction, and our system received as input that sentence and passes them to a sentiment analysis engine which use lexicon construction approach and rule-based approach to give the polarity of sentence. For the detailed architecture, the corpus construction. The corpus construction contains the data source. The data source defines the place when we have scraped our data, and the data annotation is composed from automatically or manual data annotation. So in our work, we have used the data annotation manually method. The next step is to choose an English sentiment lexicon and to translate them to MSA using Google Translated and to manually translate them to Tunisian dialect. Then we have our Tunisian sentiment lexicon. In this step, we use a term score calculation method, and then to review our Tunisian sentiment lexicon. The final step is to have a Tunisian sentiment lexicon with a score. The next step is to construct our resource. The first step is to create a strong emoji or emoticon and to create a strong expression, a booster word, and the negation, opposition term, and affixes, then to pre-processing our data set and to create a human heuristic like strong emoji and strong expression handling to use the boosting word of the Tunisian dialect and to calculate the valency of all these rules. Our work is here. Sentiment analysis for TED experimented and results. As a data source, Facebook and YouTube are two of the most popular social media platforms in the world, especially in Tunisia. We have used them to extract data between January 5 and February 24, 2022. The number of sentences collected is 1,620, and the number of validated sentences in our corpus is 1,001. We start the labeling of the sentence according to polarity and language. The sentences were labeled by me and a friend who is not an expert in the domain. In this step, we related on the approach of Germany VADER, where the labeling was done by students. The first step of double labeling that allowed use to detect a slight difference between the two annotators. In this step, we have used the inter-annotator argument matrix. And then we have our data set with a positive sentence, a negative sentence, and a neutral sentence. This is some example from our data set. The first one is a positive sentence with a polarity 1. The second one is a neutral sentence. Terms in the English lexicon circle are translated using Google Translated to MSA. Generate word in MSA are then translated to text. Some example, the word beautiful with a valence +4 means in MSA gem and in Tunisian mzien. After the translation step, the score of each English word is assigned to the translated word. In some case, we have more than one word, so we assign the same score for all words with the same synonyms. Some examples, the Tunisian word inajam means in the English side, capably, capable, able, capability, ability, empowerment. The final result is reach 500 word. Let's move on to the data pre-processing. The first step is to remove noise. This step includes a set of tasks that allow to remove the noise from the Tunisian dataset. Links hashtag. Punctuation remove. The text is tokenized, split into words, and punctuation marks are removed from the text. Arabic stop word removal. Stop words are those which are ignored during sentiment analysis. We have used the list of Arabic stop words which are also used in text. Some example before and after the data cleaning. Manual construction of research. In this step, we have chosen to create a manual rules. The first one is the strong emoji. The second one is the strong expression. The third one is the booster word. And the last one is the negation opposition terms. In this step, we related on the approach of VADER and the work of Iman Gouli for the definition and construction of our list. The test of our rules. Strong emoji and emoticon. Our first rule is related to emoji and emoticon. If the message contains a positive emoji, it is automatically annotated as positive. If it contains a strong negative emoji, it is annotated as negative. Some example from our data. This rule is the strong expression. This rule is like the emoji rule. The meaning of the strong expression influenced the classification of the message. Some examples with the polarity, the opposition handling. In the Tunisian dialect, opposition is conjugated using the pronoun amma, but, or however. The valence is determined by the component after the opposition word according to an analysis of a collection of communication including opposition. The purpose of these rules is to search the opposition word in the message. Afterward, the message focuses on the part after opposition. The score is calculated by dividing the valence of the first and multiplying the valence of the second part. Some example, we can see the word ama, and our rule check is true. The word ama and our bad check is true. The negation rule. The expression of feeling in a sentence can be affected by negation word. The use of negation word is different in the Tunisian dialect. The negation word is selected according to the negation list built before. If a negation word is found, then the valence of the sentence is multiplied by -1. We can see the negation word that means bish. Our rule negation check is true. Also, we have ما ترقدش ما ترتاحش, and our negation check is true. This is the summary of our result. We applied our rule-based approach to sentiment analysis of TED on our corpus and on Naim Hadvi corpus. Experimental result. The results shown above are very encouraging as we reach a rate of 84% for accuracy and 77% for precision. If we want to discuss our result, we can see that Tunisian VADER engine outperformed the hybrid model combining the lexicon method with a probabilist classifier which reached the accuracy of 82%. Tunisian VADER engine gives better results compared to the Helistas model which combined the lexicon approach with machine learning model and shown 73% accuracy for 3 classes of classifier. Tunisian VADER engine is more performant in a large corpus and can achieve excellent result reaching 91% of accuracy. Naim Hadvi is an expert in data science, so the result and annotation of his corpus is one of the main factors that her result outperformed ours. We have, as a conclusion, we have created a sentiment analysis engine for the Tunisian Arabic dialect based on VADER system approach. The Tunisian VADER engine is hybrid system combined rule-based approach. In our work, we have faced the lack of annotated corporal research dedicated to Tunisian dialect, the lack of lexical research dedicated to that, the lack of tool handling Arabic and its dialect for sentiment analysis classification. Thank you for your attention.